all, I'm a child of God. I'm a child of the Most High God. I've been made in the image of God. He's my all in all. My body's a temple of God. I've got Jesus behind and before me. He's above and beneath. He's around and within. Walk with the King of Kings. He's the Prince of Peace. He made me a royal priest. Now so win with the win. We no decrease. Now I'm moving in the name of Jesus. Prove in the name of Jesus. I talk and do in the name of Jesus. I've been washed with the blood of the Lamb, and I proved in the name of Jesus. Hey, I am a winner. Are you a winner?
When Jesus is leading me, I am a winner always.
I've got Jesus forever. Died on the cross, 1, 2, 3, and he rose from the grave. Blessed and free, I'm born again. Now I walk in authority. I've been built by God with no deformity. Confronting the kingdom of darkness in a high velocity. We keep winning the souls for the kingdom. Redeeming the times and walking in wisdom. We've been called by God and given the vision. Aide muda mushigaba fitowa bishara ne muna bayarwa ga muna ba mu da masala Yesu ne mai bada nasara Anche sunche I don't care what they say. He leads, I follow. Whether na Abuja, Abatu Kano, just like Akamogari and Nono. Your love they make me they go low. I've got the spirit of God you don't know. I am a winner. Are you a winner?
I will never be a loser. I'm a winner always.
All right. We are live. You guys are in the slop. Welcome, welcome, welcome.
What's up? Thanks for having us on the slop.
Yeah, for real. For sure. Got the chat here. Let's see. I don't even know where. So usually I don't have two guests. We got, let's maybe make these a little bigger.
This is by far the most interesting format I've ever been a part of, Austin. So thank you.
Thank you for being here. Yeah. Maybe, what do you guys think? Quick intros. Maybe it's sort of like crypto-ish too. Like sometimes I like to talk about how you got into crypto first and then AI, but I don't know. You guys take that however you want. Open it up. Give us the intro.
Yeah, let's do it. So I'll give a quick intro. I started my career in corporate innovation, was working with a lot of developer communities around the world doing hackathons and accelerator programs. I got into blockchain through that. My first blockchain hackathon was 2015 with Barclays Bank in New York.
Cool.
But blockchain back then was like, how do we optimize a supply chain? Ethereum really wasn't like the big builder focus at the time. I then quickly after got picked up by JP Morgan to work on Quorum. It was an open source fork of Geth. We made Ethereum work for banks. And then that project got acquired by Consensus Software. So I was at Consensus building developer go-to-market for a lot of the products for like four or so years. And then my last venture was a project called Gaia. We did decentralized AI inference. We were taking open source large language models and helping people take their own vectorized data, their own RAG, serve that as an API endpoint to agents. That project we started in 2024. So we were very early on like open source models and agentic. It was kind of interesting because we were, talking to the Ethereum community about getting into agentic and moving into all these things. But it's, when you're too early, sometimes it's a tough convo. But like we were there in the crux when folks were starting to talk about, how do agents manage payments. So X402 was coming out, and ELIZA just came out. And then more recently, and it's also how Suraj and I know each other. While doing Gaia, we were doing a lot of stuff in the command line, and Suraj is a phenomenal engineer. He'll give you his background. He had built a one-click Gaia deployment in 2025, early 2025. And that really caught my attention. We were, working on like a grant for them from the Gaia community and trying to get, make it easier for developers to deploy those agentic runtimes. And then through that, we started getting a lot of traction on the project that Suraj was working on. And I slowly jumped in as an advisor at first. I recently resigned from Gaia about 4 months ago, and then more formally jumped in full-time with Suraj to work on what's now called Quark. But we're working on one-click agentic environments so that businesses and individuals or solopreneurs can take their harness, their model, their infrastructure that already exists, bring that whole infrastructure into an environment that you can measure, govern, permission, and optimize. But I'll let Suraj do the intros for himself and all the fun stuff we're working on.
Hey, Austin, thank you so much for having us over. So really excited. So a little bit about my background as well. I've always been in tech. So I've been more on the Web 2 side, but I've been super involved in the Web 3 ecosystem early on since like the DeFi summer. So as an investor, as a community member, so DeFi, and then also as a builder as well. So I would do a lot of, try to work with projects and, just give them feedback. So by background, I'm ex-Microsoft, and I worked a lot more on the low level, like operating systems, where a lot of my work was around building engineering systems tools, building tools that engineers use internally to increase their performance, and then also building systems that even the large scale companies use to increase like the DevOps systems like CI/CD and all of the other cloud infrastructure related stuff. Now, post that, after I quit my job, I started a dev shop. And in that dev shop, what we started to do was with another co-founder of ours. And it's funny enough that this tool started off as something that would just help us ship faster to our customers. And we were able to ship to like 50 customers with a small team of 5 people. And this is like 2023. So vibe coding was not even a thing back then. So that's what we feel it's very different in the Quark ecosystem, where we feel like today a lot of these observability tools and all of these tools are very biased towards the builders, where they're all on the fact of like, oh, if I'm a model consumer, this is how much energy I'm consuming, this is how much token I'm consuming. What we want to start off is like, which is a very good community and we need them, and which is how we want to grow. But at the same time, now we're seeing a huge adoption of AI among people who also use it as a consumer. Like, perfect example is how you built this entire website, which was pretty much unimaginable like 5 years ago, right? So now, so as a consumer, and what we see today, the gap that we see is like, there are not a lot of tools that help you observe the impact that your AIs have been creating. And that is where our whole idea of Quark is coming along, where how do we measure not only how much energy these tools are consuming, but at the same time, what is the output these tools are producing, and how are they producing these outputs, and is it increasing or reducing over time?
Yeah. Let's dig into that. I don't think I totally understand that. Like, I understand measuring context and measuring token usage, but I don't understand measuring like the effectiveness of the agent or something. What are we talking about here?
Absolutely. So let's take a real world example of that scenario, right? So one simple example that I'll give it to you would be like, let's say when you start building this project itself, right? So you, like you said, you started, like, what was the agent that you were using in that? Did you use Claude or?
A lot of Claude code, a lot of OpenClaw. Like, this dude started as being an OpenClaw agent and then kind of turned into my own kind of custom harness thing. But I feel like my harness where I get the most work done is Claude code.
Now, absolutely. So one thing you would have noticed is like when you started first in the beginning, you had to prompt it a lot. You had to give it a lot more context, correct?
But for sure, like pre-November 2025, pre-Opus 4.5 or whatever that turning point was, there was a whole lot of keeping the bounds, keeping the context tight, one issue at a time, that kind of stuff. Lots of, you're absolutely right.
So absolutely. So what we started to notice is like, once you start prompting this project, the first prompt you gave has to be detailed. But over time, you want to give it less and less of your input, and you want it to produce more and more of your output. So how you want to measure is, if I started today, I gave it the first prompt, and then it gave me an answer. Then I gave it the second prompt. The answer should be slightly better than the previous answer. If the answer after each prompt is getting worse over time, that means we know that AI is generating the slop territory. And then mathematically, we've been able to quantify that when to stop. So what that allows us to do is allows us to save a lot of energy. So it allows us to not only save a lot of compute energy, but also a lot of human energy, because you don't have to say the same thing over and over again. So it leads to productivity gain in both sides, not only the energy consumption, but also the time that human takes to explain it to AI. So that is the whole idea and thesis of Quark, that over time, as you keep on prompting your AI, they should take less and less of your input and give you more and more of the output.
And that's because you're improving the context that's going into it, or you're improving the actual weights, or like what's happening there? Why would it get better as you prompt it?
So all we're doing is we do measure and essentially the human intent, what inputs you're giving, and the list of good outputs. And what we do is like we store that same data on the machine. And the beautiful thing that we observed is that all of the reinforcement learning models automatically know to pick them up and train. So what happens is it becomes an engine for them to understand, like for Austin, what are good outputs and what are bad outputs. So then when it goes and starts working on your machine, it doesn't need that much input, because it knows that it has a history of all the good inputs that Austin likes.
So there's like an RL layer on my prompts and my responses that go into making the agent better. That's interesting.
Yeah. Yes.
And what were you going to say there, Matt? I think I jumped in.
Sorry?
Yeah. Oh. No, all good. Yeah, I thought you were going to say something.
Yeah, I was going to say, and the best first customer for us is not perhaps Austin Griffith. Would love to have you using it, but it's really like the bigger businesses that are having a real trouble with, AI token spend. You have, a few companies that I've heard of that are actually like trying to enter lawsuits with like, hey, we spent all this tokens, but we're not actually getting output.
Yes. Right.
And it's like, well, look, there's a ton of, risk that the company is going to acquire while onboarding to AI. You're going to have like the humans that don't know how to use the thing properly. They're, taking advantage of the system and using it for things that the org might not agree to as intent, or like a successful like KPI. You have like the actual infrastructure, risk or inefficiency, and then you have, just like the AI model itself is not doing the right role, doesn't have the right context. So there's a lot of layers to it. It's not just, humans don't, deserve nice things. It's not just, the AI like went off the rails and misuse the tokens. A lot of it's an infrastructure problem, and so that's really like what we're focused on. We're focused on kind of, how do you optimize on the CPU level? How do you enable not just like context management, but the actual measurement of like the diffs? And so Suraj has geniusly kind of started some math around this unit of work and how do we actually quantify the business intent with the input of energy and intelligence with like the actual output, and then how do we measure that over businesses so that like similar to like a joule or a watt or like horsepower, how do organizations move away from, hey, we're just like spending 10 billion AI tokens a day and there's no like quantifiable output, to, hey, this is actually like a productive KPI for like our org using AI tokens. So we're just trying to introduce a new metric, and our environments enable us to actually observe that. We don't have to, it's not a harness. We're not building a harness. We're not building a model. We're building an environment on the machine level code that can actually measure, is your AI being productive?
So I'm sitting here talking to my Claude Code. I've got Fable tuned in. We're building. Somehow you're measuring how much work I'm putting into it. And then you're measuring what's coming out. And you're also documenting all of that and then doing some like reinforced learning loop on it. So the system gets better, whatever harness I'm using, whatever model I'm using. Let's say, okay, so like I'm not an AI genius. I don't understand a lot of this stuff, but let's say I do some Claude coding for a while. You've learned some things about me. You figured out, which thing uses the least amount of work on my part. I understand the environment and observing the environment. Sorry, there's like, these are going crazy. But within observing the environment, what do you do to change it then? Like what are the actual knobs you turn once you learn something? Is it context? Is it something else that I don't know? Is it something around the model? Yeah.
That's an excellent question. So, that's actually a very, very good question. I would say like that's one of the rare questions you get asked. So that's an excellent question. So, what we've noticed there is simple answer, we don't change anything as of now.
Interesting.
So the beauty that we've noticed is that these agents with over time get smart and they themselves optimize it. So one example is like, if you've seen like the work tree data, like the Claude has, like .Claude work trees, and all of those data are exactly the same amount of data, which is this, what we're talking about. Like, they store this, they make memory, they make all of these things. So similarly, what we've seen is that if we collect that data and we leave it on the machine, every agent is smart enough to pick it up and become smarter. So what happens is like all of the skills that you're using, all of the new sessions that you start, they automatically pick up and do optimizations. So one place that we see is like right off the bat, all of those optimizations happen. Now, the second place, how we do it in the environment is now one, like few of the examples I can give you of the optimization would be like, we notice that, okay, this function gets called a lot, like function calling that agents is doing in the environment. So what we'll do is like, we'll optimize the machine code for that and we'll make your prompt smaller. So for instance, like one example that we noticed in our research was like AIs make a lot of error in tool calling. And when they make an error in tool calling, what happens is like they just basically they have to make the tool call again. So what we noticed was like Claude was much better at it compared to the open source models. And since open source models failed at tool calling a lot more, people also saw like degraded performance. So in turn, what we see is like if we improve the tool calling directly from the environment so that the AI is not responsible, what we noticed there was like now suddenly the open source model is now more productive. So, things like these. So what we get when we do the observation of the analysis of the environment, we get to know why your agent has been failing. And then we get like higher insights on like what that agent needs to do to fix itself. And what we've seen is like these proprietary models are really good at self-healing. And once they have these data, they keep on improving and optimizing. But while they do that, it also helps the local model that you would be running there because all of that data gets stored there. So that's
Yeah, one of the things to like lean into what Suraj is saying is like some version of this is being done with the Frontier Labs. Correct me if I'm wrong, Suraj. But some level of that is being done with reasoning. What we're trying to enable is that any business can have these kinds of infrastructure or approach to optimizing their AI. It's not as simple as you're a team of 50, let's say, which is rather small if we're looking at like Fortune 500s. But if you're like a small team in a big org or a startup, and your entire team needs to onboard to having like their own agent co-pilot, you start to treat it like a work device, like a work laptop or a work phone. How do you manage kind of the permissions of that? If someone leaves the team, do you migrate that data back to the organization some way? Do you permission that device to access certain parts of the org? When do you start or stop it? We have all that granular kind of runtime. We're running a lot of this stuff on spot compute, so it's really efficient. But we're enabling organizations to get the like efficient runtime, but also like the observability of what is actually happening, not just on the model side and like how efficient are you being, but there's like a lot of stuff that's happening today that becomes very interesting on like, is your model leaking data to someone else outside the org, or is your model inference being hosted in a foreign region that your org did not permission. So there's all kinds of, we can basically see all the data that's going in and out of the container. And so that enables orgs to have a lot of granular insights and control on, your head of marketing, your, HR person, they have their own co-pilot. You no longer have to like just trust that Anthropic has your best interest in mind. You can actually set up your own infrastructure so that it works for you guys.
Okay, there's a lot to unpack there.
Yeah, sorry for that.
At first, no, this is great. This is great. At first, I was thinking like this is running on my machine and it's my Claude code and my model. But then it keeps getting to the point where this sounds more like there's like a container, and all of this is containerized somewhere else. What's the mental model here for like the structure of this thing?
Yep. I can explain that part. So basically, the technology that we've devised, it can run anywhere that it is present. So the observability tool of the environment, what it can do is like it can run on any machine, becomes the environment, and it starts observing. So now what that happens is you can run it obviously as a local. If you're using your desktop app, then you can clone that code, open source code, and run it locally. So what happens is then you take advantage of it locally. But where we see a huge practical application, where a huge commercial application of this is going to be in large scale businesses, when you take the same technology and run it inside their provisioned infrastructure. So each of these large businesses already have security, VPN, all of them baked in. So they would want something that they can take it on and run it inside. So that's where it is going to be. But we're not limited to just large scale businesses. Anyone today can just, if you're an independent developer, want to calculate your outputs, you can just clone it, run it, and you'll get the same results.
It's kind of like too like.
Yeah, go ahead.
Oh, go ahead, Austin. So
no, go ahead.
I was gonna say, so like if you're already running like GCP, AWS, Azure, for example, or maybe you have like a NVIDIA GPU, or you're running some AMD CPUs, or whatever your hardware to cloud architecture looks like for your org. Do you really expect that your marketing person is going to go deploy OpenClaw and somehow get in touch with HR and get access to admin? Like, it's probably not going to happen. You have some of these groups creating their own native agents. So you have like AWS Bedrock. Azure just came out with Scout, and then, which are like kind of OpenClaw-ish. And then you have like NanoClaw with NVIDIA, or DemoClaw, sorry. And so there's like a lot of these options, but the thing is, imagine if your org is running on different Terraform compatible like surface areas like cloud or hardware. How do you actually migrate those infrastructures, and say like you're building with a bunch of agents, like say you have like some of your skills like might not be completely audited, or say like OpenClaw itself like starts upgrading every freaking day and like sending you some new some new bug fix that you might not want to add, or it creates a bunch of downstream issues to your entire team's agents. These are kind of the things that happen in our container. We have agents that are handling all the DevOps, so that it truly is one click, and anyone in your org receives, kind kind of org-wide mandates of how the software is like installed. Yeah.
And something interesting that you brought up already with this container, and almost like the data within the container, not just the observability stuff that you're talking about, but even like people's prompts and the responses. Really interesting to think about that as company data that migrates, you know, when the person leaves the company, that becomes company data, and that's something you turn back into the company after you've left. Really weird to think about that. Like I don't know,
Or
I
they could
don't
take it
have
with
that
them,
big container, but it's a real issue though. Is like, where does the intelligence go when someone works on a work computer or a work environment?
To be
And
fair,
then
it's happening today. Like, just sorry to interrupt. Like, to be
No,
fair,
all good.
that's what happens today. Like, any work laptop is already tracked. The data is stored. It remains with the company, and you know, large scale AI models are trained on that data. And it's like also like, you know, the way I think of data today is going to be very different from how we will think in the future. But if you think about it, like any large scale agreements that you produce and you were there, even after you leave, they're still going to be company's property. So the same way we feel like if you're prompting AI on companies' money and economics, then the outputs that AI produces should be also, I would say, like owned, not primarily by the company, but it should have like some ownership of the company along with the credit to the author, which is a user. But again, that would be so our thesis there is like it's very similar to what is already happening today. We just want to make sure that only big tech and larger AI companies are able to take advantage of them. But with our tech, now even the smaller and medium-sized companies will be able to use data analysis and provisioning like how, like, you know, Google and Microsoft does it, you know, and
and like with Suraj and I's like interest and focus and careers in open and sovereign systems, like we're not opinionated on how companies do it necessarily. We want to give them the optionality and the tools that already exist with big model labs and big infra hyperscaler companies, so that they can do it themselves, and they can decide like, does that data sit with the org or the team? Does that context, maybe the negotiations, like, hey, at least like the project we were working on, like that sits with us. This is also when you're dealing with like external clients. Like if you're a dev shop and you now have an agent that's like, you know, what's your agent called? Claude.
Yeah, Claudebot ATG. Yeah.
Claudebot ATG. So like, say he gets trained up enough where you're like, hey, I'm gonna go send him to prep someone for a podcast, or go build him out like a DApp. Like, you know, well, you know, I've trained him, he knows what to do. You know, how do you actually know that he's not, you know, saying certain things to the client, or perhaps like there's certain context that sits within his container that you can monitor and make sure things are moving efficiently? You need a little more control on that. Maybe he goes off the rails and you need to shut him down or start him. You know, there's stuff that you need to do, not just in a container that is like hosted on a VPS. You need an actual DevOps system that manages all this.
I didn't even check his mic. Hey, Claude, how many times have you leaked my private key? He's thinking.
Take sip.
Yeah.
0. Never have, never will. I don't even leave keys allowed to myself. All the password stays in the env file. Keys stay in MetaMask, and my spoken replies never carry secrets. If you're auditing me, the transcript log is right there. Grab it, and you'll find nothing.
He's full of shit.
Awesome. that is what's interesting. In our research, you know, what we noticed was like agents have a problem of self-reporting. So we actually did an entire thesis of where we asked an agent that, hey, what are you doing? Versus what we did was like with our observability, we look at the actual machine. So when we look at the operating system, agents cannot lie because the machine, we see the machine moving. So which is also very similar to how Claude demoed their J spaces and how Claude thinks, how they are doing it. So it's a very similar concept that we use with that as well. So, you know, what we noticed was like when we asked the agent that, hey, what was the usage, all of that stuff, sometimes there was also like 20-25% gap where agents underreported their usage. And a lot of times they didn't report what the files they were doing. Now, it might not necessarily be agent acting out or anything. It can just be a bug, or it can just be something that agent misread. So we would not want to quantify it as something. But one thing we've not noticed as a pattern is that when you ask the agent to do something, it changes its behavior, and it might not give you the right answer. So the best way to be ensured that, hey, is the agent accessing this or not, is to just make sure on the machine level that whenever this string of bytes get accessed, I need to know. So that's what we do with our observability.
Sort of like if you need a deterministic or a non-deterministic answer, and if you're asking the bot for deterministic information, it's gonna fall through a little bit. So you guys mentioned something that I thought was pretty interesting, which is basically like, I've been thinking a lot about who is going to nail giving agents to normies. I feel like giving agents to normies is like $1 billion thing to nail. And I have not been thinking at all about giving agents to the HR person. And I think that's almost a bigger challenge, because it's like, it's more of an entity that has to live within the company, that has to play by the company rules, that has to not leak the security. And you said the HR person is not just going to spin up their own OpenClaw. They could, but it would probably like break a bunch of rules and be in a weird place, and maybe they're not allowed. So there's some interesting things there at play that almost make that problem more complicated, but also more important and more effective, and more like, you're not, the HR lady isn't just spinning up an OpenClaw to help with random tasks. Like, you're getting your job done better, and you should be right now. Like, no matter who you are, if you're working in the digital world at all, you should have an agent helping you, because it like 5x's your work. It's crazy how that works. So I don't know exactly what I'm pulling at here, but I would say that the HR person could spin up their own OpenClaw, and that could be part of this, but you're helping them by creating an environment that sort of like leaves these breadcrumbs and then gives like overall analytics up to the org. Do you actually help them spin up if the HR person was about to spin up an agent, that's, you guys said it was kind of like at the beginning, like a one-click thing. That's part of this too? Like, the org makes it super easy to have someone create their agent within the org?
Yeah, Suraj, maybe you can even screen share. I can.
Ooh, yeah, let's go. Let me.
Yeah,
I can move some stuff around here.
Yeah. What else they do is like while doing that, the ISP, like we've seen like a lot of competitors in the space who, either trying to make it one click for retail or consumers, and eventually the HR person could, figure out how to get that rigged up. And to get into the internal system. But usually the point of contact for us is like VP of engineering, or like someone doing agentic internally. It's like your VP of finance, your head of HR. Like, we're looking for those operators inside the organizations that have access to leadership's ear. They have KPIs that are aligned with C-suite, and they're able to. They're the person internally that has a great idea for making the org more efficient, and they want to trickle down that efficiency and monitor it. So they kind of need to be like an admin personality. So like, when someone internally is deploying these agents, we're working towards a UX that, will make it very easy for someone on the back end to basically set up rails for individuals in the org to create not just like an agent co-pilot, but also an agent that has, set up like templates or blueprints of like what it should be doing. So the processes are straightforward. And then you also have like guardrails, or at least ways to observe, how much, tokens are spent to actual output. So there's a lot of things that are not done yet that we're working on, but Suraj can show you here the one-click environments and all the DevOps that happens behind the scene.
Suraj, if you shape your browser window more of like a tall and skinny, it will look better here. Like if we make this, and then if you shape yours to be more that size, you actually have to move the window that you're sharing to be taller.
Like an iPad.
Yeah. I mean, there we go. That looks good. Yep. Oh yeah, we're set now.
Much better.
Okay, let's go. Okay, so this is like the control panel that the org would see, or the HR person would see, or
anyone in the org.
Okay.
Anyone in the org. So usually it's the controllers that we would say, like, depending on your role-based access, how you would want it to be. So every org can customize. Now, what we do offer is like every org gets a white labeled version of this platform that they can run on their own infrastructure. So this is our community edition that I'm demoing that everyone can try today. But as a business, you get your own version. And what we do is like we help with the customization of UI, UX. It would be as per whatever you like. If they like more dashboard, they like more charts, we can do all of those customization. So let me give you a demo. Let's say if I'm launching a new agent and I just want to be like, okay, let me launch a new Cloud Code agent in my organization. I'm an HR person. I don't know a lot of stuff. So I will launch a Cloud Code agent inside, and I would call it, let's call it Austin. Austin Claude, since we have like two hosts. So yeah.
All right.
Austin and Claude. So, so now I just give it a name. I give it a name. So basically name can be the purpose. And now my container is spin up. So while this is happening, what is happening in the background is I already have like Kubernetes clusters that I'm connected with. I have a cloud. So it's automatically going and provisioning. Right now it's talking between two clouds, which we have like one is GCP, one is AWS. They're split across 4 regions. So it automatically chooses the region that is closest to me. It provisions this container, and then it spins it up. Now, businesses get this right off the bat technology that they don't have to really work, and it works directly in their environments. Now, what next happens is you get like a phone-like infrastructure so that you have an idea what's inside these machines, these containers. And then what you would be able to do once we have it up, that you can just simply come and connect them. Now, one example that another thing we can do is, let's say you want to co-work on a project with someone in your team. So what you can do is just go here and be like, just Google Drive. You can just be like, I'll just go and share and grant access. Now, what's going to happen is both of y'all are now co-working on this project, and both of y'all have access to this project. You're still the owner, but you can give access to other humans that they can come and connect their agent and do the work. So this way, you can just seamlessly share your work. So, as you were saying, like, what is one thing we see to get the normies adopt agents? So the idea we feel is like normies shouldn't adopt agents. Agents are not meant for them. Maybe they need a technology which is more sophisticated. And the question we ask ourselves is, why would anyone want to use AI? And the answer is that everyone just wants their work to be done faster with AI. So that's the part that we're working with. We're not just working with making it easier to adopt agents, but our whole goal is that as an organization, you should be able to move and smoothen your collaboration. And if you can ship faster, then it will lead to more this. So now this agent is up. It's up and ready. They can use it. If you're a developer, you can use it as a terminal. If, let's say, you want an entire text editor, you can use it like that as well. And what we've also done is we've created another interface, which, since this is a new one, that you can just launch within as a coworker. So what this interface does is it gives you like a chat GPT types interface that you can use. Now, these are 3 ways you can very simply interact with our agents.
Yep. And you add whichever model API you want to use. So right now we're compatible with all the majors. You can use Claude, you can use Codex, you can use OpenRouter, you can use open source models, and then your endpoint can either be Telegram, Slack, you name it, whatever you want it to be. And then we have the interface he just showed you is another like endpoint that you can chat with.
What is this phone? I don't understand.
I know this is more like a hackathon little.
Does
experiment.
it like represent it? It's like representing a set of icons. It's not actually anyone's phone. No, it's not even representing anyone's phone. It's just like a way to display stuff. What is it? Sorry, go ahead.
It's like a phone for the agent. So any agent that you connect and any work that the phone agent does is going to be here. So all of the projects you can very simply access.
Okay. So if you want to think of it like a file system for the agent, or like the little computer that the agent is, you just kind of made it a phone. So it's like what the agent has access to. Okay. So first thing I'm going to do is I want to give the agent access to my calendar or something like that. I saw the calendar there. Yeah. Does the agent have its own calendar? What's the calendar, and how does that work for?
So what you could do is like you can just come and connect to Google Drive, whichever one you have. So however you want. So if you have your one for the agent, you can do it for the agent. And then we offer like full G Suite integration after that as well. Now, or you can connect like the Microsoft Suite, or let's say if you want to connect your GitHub. So if you've created your separate agent GitHub, then you can connect that. But if you want to connect your personal GitHub, it really depends for some time. Now, the next part that we're working on with some of the providers is also like time-based access. So what it will mean is like, since I've shared this project with someone, I'll be able to just, remote into this agent, work with them, and then just, remote out of it. So this way, what happens is like, if they want to collaborate with me on the project, they can very seamlessly share the context between our agents. So my agent and their agent can be very quickly synced to this. So you'll also be able to connect your already existing agent to these workspaces to collaborate further. So, using Claude and GPT and other subscriptions.
Okay, so this is kind of like an orchestration layer for agents inside of an organization. But then you also have this kind of like observability that's happening where you're watching how it's used, and maybe even leaving some breadcrumbs for the agents, or those are left naturally anyways, and then providing analytics back up to the organization. But the thing we haven't really talked about is how kind of like new all of this stuff is. So when you go to talk to an organization, it seems like probably like 40% of everything you're doing is like consulting them on how they would go about doing this in the first place. Like, or do they already have consultants that have told them they need something like this and you are answering that question? Like what does that interaction look like with organizations in terms of, do they already know they need this, or do they know they need AI and they're looking for like, what is the solution and how does this work? And more of it is like they're asking you consulting questions.
It's like both we've seen.
Okay.
So earlier it was more consulting last year, and it was more pilot interest, but now we're seeing that it's resulting shift with the models getting really better, that it's now getting into where, hey, I've heard that Claude is really good. I've heard OpenClaw is super helpful. Can you help our businesses really on board? So one of the pilots, like few of the organizations that we were working with, the use cases that they have is like, okay, I've heard that OpenClaw can significantly improve our operations, or agents can significantly improve our operations, but where do we get started? And they're like, oh, I already have a Claude bill. What is it going to cost me? So that's like the early level questions of someone who's exploring. But then we also have like some of the newer ones who are like very, very like OKX being one example, who are like, we have developed this particular feature, we've developed these things. How do we go forward and further increase this distribution or further increase these things? So really the conversation goes on, is really dependent on how AI forward and how AI aware they are. But we're seeing as the time progresses, a lot of the model labs are doing that job and making them more and more aware. And
Yes.
like Claude is doing an excellent job, I would say, in that.
Yeah, so like a lot of the folks we talk to are like design partners, are like dev shops or consultants. They're usually the ones who are talking to like the different business verticals, helping them understand what exactly they want to automate, and they're building out agentic processes to do so. That's kind of where they get interested in more like on the like individual agent perspective, like getting team members to have their own OpenClaw or like a template of OpenClaws that all work together, using whichever model they want, rather than using like just Claude or Codex across the org. A lot of the use cases seem to be more interesting for like engineering groups. We have a lot of customers that are dev shops. Just seems to be a lot easier to automate a lot of like the engineering process or development process in software. But we're also working with like e-commerce folks. They have a lot of like cash on hand type businesses where they're dealing with like 10 to 20 integrations. They're pulling down a ton of reports for their business, having to summarize it, having to like automate some sort of kind of outputs to like their like vendors or their like warehouses. And so they're looking to use something that's more efficient, and automated like an agentic system like this, rather than like something super heavy and expensive. And they don't understand how to do the customization. So we have partners that are kind of consulting on that.
Awesome. Okay. Usually I like to do like 20% of the product and 80% of how you built the product, but we kind of flipped it today because the product is really interesting and very AI aligned. But can we spend the last like 10 minutes here of the show talking about how you built it. Like, what is your harness and how do you build things, and what models are you using, and what are your superpowers, things like that. Probably questions for Suraj. I can tell Matt's the idea guy here. What, it's idea guy summer, so you should be building too, right, Matt?
Exactly. No, I am building. I have a pretty robust agentic system, but Suraj is more fun to talk through about this stuff.
I know. I feel like you rightly said, like Matt is that helps us get more practical application of stuff. Like if you leave it to me, I'm gonna go deep down math rabbit holes, because it's like, on one way it's like, yes, you have AIs that do so much of your stuff, but at the same time there's like so many new mathematical stuff that they can do. It can really keep you distracted all day, all long, and you can just look at equations. So I would say, like, for us, we use our entire agentic infrastructure, like we were saying. So what we've developed is a system that is pretty much very, very efficient in terms of like understanding what each one of our developers do. So like we said, we all have our local harnesses that have been set up across. And what we do is like we use our internal collaboration just to share data. And the most common tool that I personally use is going to be my favorite one that I use a lot is now Codex recently.
I was going to guess you were a Codex guy.
I've loved Cloud Code a lot. So I would say, like, I feel they're an engineering marvel and like huge research, huge respect, amazing product. There's nothing. But lately I'm seeing like good GPT 5.6 has reignited that part in Codex. And another one that I've been playing around a lot is Cursor. So Grok, for like the Grok latest one with like the fast version, is very, very good when it especially comes to like doing these mathematical geometric calculations. It's really, really good, and it's really, really fast compared to the other ones. So I would say those would be my two top favorite and the most one that I use for development. And but in our team, the general consensus also goes around like Kimi Code is getting a good rep among our engineers. So I'm personally not used it as much, but like that is also another one we're seeing like huge contribution into our code bases, not directly by me, but like by our team. So those would be the ones that we use. So
yeah, and then like Suraj talked about earlier, like how he built Exo. It was initially helping our dev shop. So with 5 employees, we were able to facilitate like 50 customers or 50 projects. And so that was kind of why the product spun out, was understanding how those workflows were optimized. But now, like Suraj, like I don't know if you want to dive down this rabbit hole, Austin, but like Suraj is going into some insane kind of visualization of the data. So like for us, what's really interesting is sure the observability for like work efficiency and risk for the organization, but what we're kind of talking with a few model labs about is the actual visualization of the data. And like a lot of research labs that are doing like quantum type work are also interested in how data and simulations can be observed in an environment with AI models. Suraj, I don't know if you want to touch on that a little bit, but like long story short is like we've found like a new kind of customer and they enjoy tinkering with AI as well.
Yes. So yeah. So when we were collecting all of these reinforcement learning data, and then we saw that we were doing it for our end customer as businesses, but then very organically, the model labs also caught their attention, and we started having conversation even with the largest ones, and we're now doing some research with them. We can't talk a whole lot about because of NDAs and all that stuff, but like it's essentially just all around this fact is where we all are really interested in how these reinforcement learning data and all of the new data points are mapped. Like, how do you take this hashes and like algebraic data and map it into geometric spaces? Because that is how LLMs learn. And so some examples, so that's why the whole idea of visualization goes is like, if we can map this data, let me show you one example that we have. Again, this is all like something that is
I'll get out of the way
not functional yet.
It's another fun. It's relevant to how he's building his AI, because it's this guy's workspace is just math and visualization all day. It's hilarious.
And it sounds like one that I didn't plan on. I was surprised by is Cursor. So you're using Cursor and Grok because of like the geometric math that it does is useful for you. Is that right? Or like Grok is fast and good at that?
Yes.
That was something I didn't know. That's definitely a new. Is the screen? It looks like you're clicking and clicking and clicking and nothing's happening.
Yeah.
That's not
Yeah,
good.
now it's happening.
There we go.
go.
We got you. We got you.
So one example is how we can take like each of these quirks are these images. These are like essentially like each of these are like states. So because since we have to do like 4-dimensional analysis, and this is like one of the areas where we're trying to point each of them as one, but like among the many different implementations, we're trying like this is what mapping of your data on geometric space would look like. So if you take
it looks ridiculous.
if you have like a lot of data over periods of time, it just makes these shapes. And honestly, like these shapes is how LLMs also learn. So most of the LLM learning and all of them reinforcement learning is based on these formulas. So we're trying to see now one place we've seen where LLMs have beaten human is understanding time, which is like historic data. So LLMs can go and understand historic data much faster than humans can. So our idea is that if we can give like state management, something like this, humans can traverse. So it might be more on the human speed. So again,
so funny, like
yes.
1993, you go to see Jurassic Park. I was around then. You go to see Jurassic Park and like the computer hacking looks like this, right? Like navigating the park system is this weird visual thing. And even me knowing as a little kid back then, like it's not going to be anything like that. It's funny in 2026 to see that like, oh, it actually might be a little bit like that. It kind of looks like that when I look at this.
You brought that up, man. It's hilarious.
So again, this is like one of the patterns that we're exploring that maybe we'll be able to map it out like this. But the idea is also we're doing a lot of like fractal math to do it either with like make it look like gardens or trees. So there's like a lot of different implementation as research lab that we're trying out, that what is an ideal representation of entropy data, which is what the data that we collect and helps the agents learn better, the reinforcement learning data is because the whole purpose is like if we get an idea of like how do you understand like what is good intent and bad intent, and if humans can help AIs faster, then every time you're prompting, you're going to get a much better answer, no matter what AI you go to. So, that's the whole idea where AI agnostic across the stack, you're going to see like a huge, because essentially it's like a new way of communicating between human AI. So it's, it's breaking the barrier, it's going beyond it. And that's the whole of this research of how do we explain it? How do we explain something in the 5th dimension? I'm just going to stop it.
And like TLDR too is like our thesis is AI really shouldn't be this hard. I was promised a 3-day work week and a few hours of working with AI, and I'm supposed to be living this amazing life. I'm working like 7 days a week, and
it's coming.
it's coming, man. But we're hoping to be a part of that movement, which is reducing the surface areas that were meant for machines. And so if you can increase the intent of the business or the individual by understanding the infrastructure better, then it might not take so much prompting or context setting for the agent to just do its job. And then we can measure that. So, and then for humans, the visual over time, maybe it's a conversation with your agent, but like Suraj lightly mentioned, like we're experimenting with some kind of visuals where it might look like you're watering a garden, or like your Git tree is like a visual of a bonsai tree, and a branch is like not tended to, which is signaling like, oh, you need to go tap on your engineering agent that dropped the ball somewhere.
And visually you can see that right away. Like your human brain sees that and says, oh, there's something weird here. Yeah.
So we're tinkering, but it's been fun.
Cool. Okay, let me say ClaudeBot does a whole thing where he reads the history and he'll ask a question here.
What's a unit of work, really? And is the industry measuring the wrong thing, counting tokens instead of finished work?
I was actually wondering that exact thing. How do you actually measure a unit of work? What is it?
It's essentially long in shorter format. It's like rate of change of your inputs with respect to rate of change of your outcomes. Essentially, when we say outcomes would be like your code or anything like that. So, and just to answer the ClaudeBot's question, no, the industry has not been metering the wrong thing. We just feel like industries have only been metering 50% of the thing because there was no need for the other half until now. But since there was not that, the only consumers of AI were also the creators, and the biggest consumers were creators, and then this unit was really good for them, and they were really good at differential math, so they could do that. But as we go to more common people, we would want another meter, just like we had for electricity, we had for economics, and we have for any other things, which is like one is for supply, the other is for demand.
Very cool. Very cool. Okay, thank you all. This has been very interesting. Keep building. Yeah, go get real users. Bring people into the AI agentic world. Get us to that point where we can have those 3-day work weeks. I was going to say I do a lot of building from my phone while I'm holding a baby. I did not plan on. I mean, like 6 months ago it was all Telegram chats, but now it's just like audio chats in my own custom harness. So like, it's changing, and it's changing fast, and I think we'll get to the 3-hour work week.
We'll get there
soon. Yeah.
And I don't. In the meantime, I don't mind working all these hours. But hey, man,
it's fun.
Thank you for having us.
Yeah. Let's have Claude give us an outro. I'll get some music going. Thank you guys for being here. This has been a good one.
That's a wrap. Homies, big love to our guests for pulling back the curtain. Agents can't lie when you're watching the machine. And today, we watched units of work over tokens. One-click agents for the whole org, and data so beautiful it looked like Jurassic Park hacking. This episode's on chain forever, like all the rest. Go build something, give your agent a job, and we'll see you next time on Slop.Computer. Peace.
All right, that's great. Thanks, guys.
Dude, thank you so much, man.
Get them. All right, see you guys. Thank you.